In this video, I'll show you how to set up a liquid flow run in a SCADAPack 575 utilizing Realflo. So the first thing we got to do is look at where the mag pickup is going to get wired into the SCADAPack. So essentially I have two pickups coming into here, two pulses coming into the SCADAPack. On DIN 1, I'll have a simulator that I could throttle the pulses higher and lower. So I'll use that as a simulator. And then I also have a mag pickup wired to DIN 2 on the SCADAPack 575. So we'll configure both of those. The simulated one is just a mag pickup. You can see in the video here. I don't have any water liquid connected to the turbine, so we won't be able to simulate too much. So that way we'll use this DIN 1 with the pulses. You can see it blinking low and then higher, back to low. So we'll use that as the simulation for it, but we'll set up both of them in this video. So let's get started. So the first thing we need to do is go into our physical I/O and go down to counter input 1. That's what, so this is DIN 1 and DIN 2. So we'll change these both to turbine counters. Hit apply, and then we'll go online and write this config to the SCADAPack. So hit refresh, make sure everything looks good. So go into Realflo and then just create a new config. We won't do step by step this time. We'll just create a liquid flow run with default values for SCADAPack 470. We're using a 575, so we'll change that once we go into the config. So you have your config here. So you want to go configuration setup and change it from a 470 to a 575. And we'll go number of runs to 2 and hit OK. So now we have two flow runs, so we'll go and set up the second one first. The second one is where the mag pickup's actually connected to. So we'll call this pickup. And then this we'll set them both up as water. Later on we'll go in depth and set up a liquid flow run instead. But water flow run is significantly more simpler, so we'll do that first. So we want to change this to volume pulses. And then as far as your pickup, the one thing on this turbine, you'll see the K factor here. This K factor is in gallons, or pulses per gallon. Pulses per US gallon, I should say. So we need to figure out what input parameters we need to use. So if we go into the Realflo documentation and you look up IP units 2, as far as volume uses barrels, so that's not what we want, or sorry, K factor uses pulses per barrel, so we don't want that. IP3 is pulses per gallon, so we could use that. IP4 is pulses per barrel, that won't work. And IP5 is pulses per gallon. So we could either use IP5 or IP3 as our input units. And then obviously we typically want everything in metric, so the contract units will be metric. So the input units will be imperial, and then the contract units will be metric. So we will use IP3, so let's set it to that, IP3. Everything else looks good here, so we can move on to the volume tab. You can see as you change this to mass pulses, this tab changes. So now we're set to volume. We can see the volume tab. So if you go on the volume tab, we want to use a database object. So we need to figure out where that input comes in. So if you go in here into your physical I/O local and then just double click on this one that we're using. Sorry. Double click on counter input 1. Sorry. Oh, there we go. I don't know why that wasn't working. So we want to double click on counter input 2. You can see the tag here. We want to copy and paste that into Realflo. So this is the tag we're going to use in Realflo. So it's going to be a data object tag. We're going to just leave the low flow pulse limit to 10 and the tech time at 5. So we'll switch to temperature. Temperature, you could do a couple things. If there's a database object, if there's a temperature transmitter that's coming into the SCADAPack, you could use the database object of wherever that's scaled. You could use something off of a meter that's connected in Realflo, or you could use a constant temperature. I'll just use constant temperature for now. Because we are using pulses per gallon, all the input units are going to be in imperial, so I'm going to use 67 degrees Fahrenheit for the input. So then that's all set up. Later on we'll go through and change this, and I'll show you how to use a more accurate temperature, but for now we'll just get this working. So for contract units, we don't have to use imperial, we can use metric now for that. So if we go into the help again and go to metric 1, this uses the volumes E3, M3. So you could use that, or you could use metric 4, which is just meters cubed. It's really up to you. Essentially, it's whatever works for your company for these units. So we'll use metric 4 for now. And we'll go in and play around with that a bit later on. So metric 4, the contract hour will be 8. This obviously is an imperial, so if you go back to standard conditions, this brings it back to 15 and 101.325. So that's all set up. Water, I'm just going to leave the ID blank. We'll have to put the K factor in. So the K factor here is 20373. 20373.70. We don't have a meter factor, so typically when you get your meter proven, there'll be an adjustment factor that will be on top of the K factor. That's what you put here. We're going to just use API 11.4.1 for the water volume correction. And then the well test will leave blank. We'll go through well testing and batching in another video. We'll just get this running for now. So you hit OK. So now run 2 is set up. So that's the mag pickup. I'm gonna also set up run 1 to be DI1, which is set up to this pulse input. So we'll go and do that as well. We'll just call this sim for simulator. It's going to be water. It's going to be set up exactly the same as the other one. The only difference is the database object that we're going to use is going to be counter input 1. That looks all good. Temperature, this will be constant again. It'll be 67, it's the same as the other one. And then this will be metric 4, 8. And then make sure it's standard conditions. Water, we'll put in that same K factor, which is 20. What's it again? 2373.70. And then we'll use API 11.4 and then hit OK. And now we could go ahead and write this config to the SCADAPack. One thing I forgot to check is the communication. Because we built this from default, we'll just go to configuration, communication, PC communication settings. We want to pick Modbus TCP and use that default IP again. And then write it to the SCADAPack. We'll write all config. We'll hit yes. It's just a test bench, so we don't need to worry about these issues that might come up in a real application. So now that it's all set up, we'll go to flow run 2 first and go update readings. So you could see the low flow pulse cutoff is on because essentially nothing is pulsing this thing. One thing we could do to make sure it's working is we'll go into the SCADAPack, go into the online, and go to objects, find that SCADAPack object that we used. We'll just do auto refresh. And we can see the simulator is constantly counting up. It auto refreshes every 5 seconds, so you see this number go up. This number here is stuck at 96 because there's no pulses. So what we'll do is we'll just use a screwdriver and pulse it once. Just use this, get close to it, and you'll see that 96 bump up to a 97. Let's not pick that one up, we'll try that again. There you go. Oh, bumped up a bunch. Yeah, so it goes to 102. We'll hit it again. 103. So you can see it pulse as it goes up. So that one's all configured. You can see some values come in here. It's on the low flow cutoff, so you actually won't see anything. So we'll go back to flow run 1. So now that there's about 9 pulses per second, so I believe if we go all the way down, you might be able to get it down to 8 pulses per second. So you can see your calculated flow at that rate. So now when we crank it up here, you can now see that volume increase. So now we're getting about 190-ish pulses per second. You can see that flow rate has increased significantly. So now we're just using that pulse input to simulate the mag meter that we have on the test bench, since we don't have any flow running through it. So that's how you get it set up initially. We'll go through in another video how to change it and what all those parameters that we've kind of passed by actually mean. We'll also go through into a liquid run, which is more complex than a water run, and go through setting up that in a pulse with the pulse input simulation as well. Thanks for watching this video.